There is a mechanism related to phagocytosis which is called opsonization. Opsonization makes phagocytosis more efficient. Opsonization involves an interaction between neutrophils and antibodies against foreign antigens in the body, phagocytic cells, and these antibodies seem to be very good friends. Quick review. Antigens are substances, typically proteins and polysaccharides, be it from the body, from a pathogen, that can be recognized by the immune system. Non-self antigens usually trigger immune responses, but still, a certain criteria must be met for this to happen. Antibodies, on the other hand, are responsible for eliminating pathogens in the body as much as phagocytic cells. There are various classes and each has a different respective function. Here is an example of the process of opsonization. A foreign antigen from a pathogen usually binds to an antibody in the body. An antibody, usually an IgG, has an Fc portion. Neutrophils now have this FcYR receptor on their surface which binds to the said Fc portion on the antibody. Once they attach with each other, the phagocytosis of the pathogen is made more efficient. It makes the process more efficient because the pathogen-antibody attachment helps the neutrophils find invaders that it needs to phagocytose, unlike in the nonspecific process if it is without opsonization. The neutrophils would then phagocytose this pathogen as usual. Phagocytosis takes part in the innate immune response of the host to the injury or infection, as the white blood cells engulf and destroy the foreign substances present in the host body. Not only does phagocytosis act against pathogens, it also eliminates apoptotic cells to maintain tissue homeostasis. This happens as the white blood cells, with the help of receptors in the plasma membrane, recognize and determine the target cells for the initiation of phagocytosis. Although phagocytosis is a non-specific resistance that targets most of the foreign substances, some bacterial species still manage to evade phagocytosis. An example here would be Staphylococcus aureus that secreted extracellular fibrinogen binding protein which binds to the complement protein C3, reducing the opsonin recognition and evading phagocytosis. To add, impaired phagocytosis can also lead to autoimmune disorders as apoptotic cells remain inside the phagocyte if the oxidative or respiratory burst did not happen, leading to the development of autoantibodies. An example of this disease is the chronic granulomatous disease, where there is a defect in the enzyme that is linked with the NADPH oxidase, causing the cells to have a decrease in the glucose utilization.